All right, so we're gonna move on right now to the volume part. So all what we've done so far is the surface area, okay? So we're looking at how much material does it take to create something, to make something, right? So when we're talking about the surface area, we're talking about the area of all the sides, and we're adding them together, right? But now moving to the volume, we're gonna talk about how much space does that object take, okay? That's what volume means, or how much volume can you fit inside of it, right? So when you're talking about, let's say, a cup, and you say the cup can contain 500 milliliter, right? That's a volume. This is how much material I fit in that cup, okay? So we're finding the volume of different shapes. The volume, for example, we're gonna start with a rectangular prism, right? So for a rectangular prism, to find the volume, you need your length and your width and your, you need all three sides, okay? If you know all three sides, the formula for the volume of a prism is length times width, height, and then you can multiply them all together. And that would give you the volume of the rectangular prism. Now, what would be the unit for a volume? In this case, I'm multiplying centimeter by centimeter by centimeter. That's going to end up with a centimeter cube, because you're multiplying it 3 times, okay? So all the time when we're talking about volume, now we're going to convert. Later on, we're going to learn how to convert this to liters or to milliliters, because we don't say, well, I have a 500 centimeter cube water bottle. Doesn't make sense, right? We usually use 500 mil, right? So we need to convert between the measurement of the volume to the actual measurement, which is the liter, milliliter, all of these, okay? Gallons. So we'll look at how we can convert. When we get to the volume part, I don't care if I have a top or if I don't have a top, right? The volume is going to be the same regardless, right? The volume of this rectangular prism, right? The volume of this is going to be the same regardless if I have the top or if I don't have the top. It's still going to fit exactly the same amount, okay? So determine the volume of a box if the base has a width and length of 18 and 24 inches and the height is 16 inches, okay? So I know my length and width and I know my height. So it's a matter of just multiplying them all together. Make sure that when you do that all your units are the same. And then at the end, you're going to have to make sure that you report your unit cube, okay? So in this case, it's going to be inch or cubic inches. I always feel that the volume is easier to find than the surface area, because the surface area, by removing one side, then now you change the formula, right? And you have to figure out the formula, right? With the volume, it doesn't really change things, okay? Okay, so I'm gonna let you work a little bit on this question. Now, this is a composite figure, right? Where I have two rectangular prism next to each other or combined together, okay? So if you want to find the volume of this, what would you do?
Would you do what we did in the last thing, we made it into like squares and stuff?
can make it into two different rectangular prism, right? So if I actually cut this in half, right? Right? Find the volume of this. Find the volume of this. Find the volume of this, and then combine them. Add them together. Okay? So I want you to try that. Don't tell me this is not working. No, it is